हेलो बच्चों, इस एपीसोड विच तुसी ज्योमेट्रिकल रिप्रेजेंटेशन ऑफ प्रोडक्ट एंड क्वोशिएंट ऑफ टू कॉम्प्लेक्स नंबर्स बारे जानोगे। तुसी पहला तो ही इन्हां बारे जरूर जानते होवोगे। कॉम्प्लेक्स नंबर्स, ज्योमेट्रिकल रिप्रेजेंटेशन ऑफ ए कॉम्प्लेक्स नंबर, कंजुगेट ऑफ ए कॉम्प्लेक्स नंबर, मल्टीप्लिकेशन ऑफ कॉम्प्लेक्स नंबर्स, मल्टीप्लिकेटिव इनवर्स ऑफ ए कॉम्प्लेक्स नंबर, डिवीजन ऑफ कॉम्प्लेक्स नंबर्स अते पोलर रिप्रेजेंटेशन ऑफ कॉम्प्लेक्स नंबर्स। आओ हुन शुरू करिए।
Multiplication of two complex numbers. Let z1 is equal to x1 plus iota y1, z2 is equal to x2 plus iota y2 be two complex numbers. Then their multiplication, that is z1 into z2, is equal to x1 plus iota y1 into x2 plus iota y2, that will be equal to x1 into x2 plus iota into x1 into y2 plus iota into y1 into x2 plus iota square into y1 into y2. That can be written as it is equal to x1 into x2 plus iota x1 into y2 plus iota into y1 into x2 minus y1 into y2, because we know that iota square is equal to minus 1. So it is equal to x1 into x2 minus y1 into y2 plus iota multiplied by x1 into y2 plus y1 into x2. So, for the given complex numbers z1 and z2, z1 into z2 is equal to complex number with real part as x1 into x2 minus y1 into y2 and imaginary part as x1 into y2 plus x2 into y1. To find the product of two complex numbers geometrically, consider two complex numbers with polar coordinates. Let the two complex numbers be a z1 with coordinates r1 theta and b z2 with coordinates r2 beta in the origin plane. Now consider the real axis and imaginary axis with O as the origin. The two complex numbers represented by points A and B are drawn with OA equal to R1 and angle AOX equal to theta, OB equal to R2 and angle BOX equal to beta. That vectors OA and OB represents the complex numbers Z1 and Z2. Now draw a triangle OAL such that OL lying on real axis has unit length. Also, construct another triangle OVP similar to this triangle OAL such that angle POB is equal to theta and OA and OP are the corresponding sides of these triangles. Since these two triangles are similar, the ratios of corresponding sides of these triangles are also equal. Solving this equality of ratios for OP, we get OP is equal to R1 into R2. Also,
angle POX is equal to sum of angles, angle POB and angle BOX.
that is, it is equal to theta plus beta. Thus, P is the point whose modulus is R1 into R2 and argument is theta plus beta. So it represents the product of these two complex numbers. So polar form of complex numbers represented by vector OP is R1 into R2 whole multiplied by cos theta plus beta plus eta into sin theta plus beta. This point P gives the multiplication of complex numbers represented by points A and B. To see the geometric representation of division of two complex numbers, consider again two complex numbers with polar coordinates. Let the two complex numbers be A Z1 with coordinates R1 and alpha and B Z2 with coordinates R2 beta in the origin plane. Now considering the real axis and imaginary axis with O as the origin, the two complex numbers A and B are drawn with OA equal to R1 and angle AOX equal to alpha, OB equal to R2 and angle BOX equal to beta. Now draw a triangle OBL such that OL lying on real axis has unit length. Also construct another triangle OAP similar to this triangle such that angle POA is equal to beta and OA and OB are the corresponding sides of these triangles. Since these two triangles are similar, the ratios of corresponding sides of these triangles are also equal. That is, OA upon OB is equal to OP upon OL implies that OP upon 1 is equal to R1 upon R2. Also, angle P of x is equal to angle AOX minus angle BOX is equal to alpha minus beta, as angle AOX is equal to alpha and angle BOX is equal to beta. Thus, point P is the point whose modulus is R1 upon R2 and argument is alpha minus beta, and it represents the division of these two complex numbers. So polar form of complex number represented by vector OP is R1 upon R2 whole multiplied by cos alpha minus beta plus eta into sin alpha minus beta. This point P gives the division of complex numbers represented by points A and B.
ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਜਿਓਮੈਟ੍ਰੀਕਲ ਰਿਪਰੈਜ਼ੈਂਟੇਸ਼ਨ ਆਫ ਪ੍ਰੋਡਕਟ ਐਂਡ ਕੋਸ਼ੀਐਂਟ ਆਫ ਟੂ ਕੰਪਲੈਕਸ ਨੰਬਰਸ ਬਾਰੇ ਜਾਣਿਆ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Now let's see an example. Represent the following two complex numbers given in the polar form on the complex plane. Also, find their product and represent it on the same plane. The given complex numbers are Z1 equal to square root 2 into cos pi by 4 plus eta sin pi by 4 and Z2 equal to 2 into cos pi by 3 plus eta sin pi by 3. Now its solution. Here given complex numbers are Z1 equal to square root 2 into cos pi by 4 plus eta sin pi by 4 and Z2 is equal to 2 into cos pi by 3 plus eta sin pi by 3 Here given complex numbers Z1 and Z2 are in polar form. Now comparing the given complex numbers Z1 and Z2 with the general polar form, that is Z equal to R into cos theta plus eta sin theta, we get for Z1 R1 is equal to square root 2 and theta 1 is equal to pi by 4, that is equal to 45 degrees. For Z2 R2 is equal to 2 and theta 2 is equal to pi by 3, that is equal to 60 degrees. Now representation of these complex numbers. That is Z1 and Z2 in the organ plane to represent Z1 into Z2 on the organ plane. First, take a point L of unit length on the real axis, making a triangle OAL. Also, construct a triangle OPB similar to the triangle OAL with angle POB equal to 45 degrees. So here angle POX is the sum of angle POB and angle BOX, that is, it is of 45 degrees plus 60 degrees equal to 105 degrees, and OP is equal to 2 into square root 2. As the sides of these similar triangles OAL and OPB are in the ratio 1 by 2, that will provide OP is equal to 2 into square root 2. So here OA equal to square root 2 and angle AOX is equal to 45 degrees. Therefore, point A represents complex number Z1 Further, OB equal to 2 and angle BOX is equal to 60 degrees. Therefore, point B represents complex number Z2 . Now, for the product of Z1 and Z2, that is Z1 into Z2 is equal to square root 2 into cos pi by 4 plus iota sin pi by 4 into 2 into cos pi by 3 plus iota sin pi by 3 that will be equal to 2 into square root 2 into cos pi by 4 into cos pi by 3 plus iota into sin pi by 4 into cos pi by 3 plus cos pi by 4 into iota sin pi by 3 plus iota square into sin pi by 4 into sin pi by 3 that is further equal to 2 into square root 2 into cos pi by 4 into cos pi by 3 plus iota sin pi by 4 into cos pi by 3 plus iota into cos pi by 4 into sin pi by 3 minus sin pi by 4 into sin pi by 3, because we know that iota square is equal to minus 1. So we can write it as it is equal to 2 into square root 2 multiplied by cos pi by 4 into cos pi by 3 minus sin pi by 4 into sin pi by 3 plus iota into sin pi by 4 into cos pi by 3 plus cos pi by 4 into sin pi by 3 because we know that cos of A plus B is equal to cos A into cos B minus sin A into sin B and sin of A plus B is equal to sin A into cos B plus cos A into sin B now it will be equal to 2 into square root 2 whole multiplied by cos of pi by 4 plus pi by 3 plus iota into sin of pi by 4 plus pi by 3 So it is equal to 2 into square root 2 into cos 7 pi by 12 plus iota into sin of 7 pi by 12. So therefore Z1 into Z2 is equal to 2 into square root 2 whole multiplied by cos 7 pi by 12 plus iota sin 7 pi by 12. So here this is a complex number represented in the polar form. So here modulus of Z1 into Z2, that is R, is equal to 2 into square root 2 and its argument, that is argument of Z1 into Z2, that is equal to theta, is 7 pi by 12, that is equal to 105 degrees. Now representation of Z1 into Z2 on the organ plane So here OP equal to 2 into square root 2 and angle POX, that is equal to angle POB plus angle BOX here is equal to 45 degrees plus 60 degrees, that is equal to 105 degrees. So therefore we can say that point P represents product of the complex numbers Z1 and Z2 ਤਾਂ ਇਸ ਦਿੱਤੇ ਗਏ ਐਗਜ਼ਾਮਪਲ ਲਈ ਅਸੀਂ point A ਨਾਲ ਕੰਪਲੈਕਸ ਨੰਬਰ Z1 ਨੂੰ ਰਿਪਰੈਜ਼ੈਂਟ ਕਰਦੇ ਹਾਂ, point B ਨਾਲ ਕੰਪਲੈਕਸ ਨੰਬਰ Z2 ਨੂੰ ਰਿਪਰੈਜ਼ੈਂਟ ਕਰਦੇ ਹਾਂ ਅਤੇ point P ਨਾਲ ਕੰਪਲੈਕਸ ਨੰਬਰ Z1 into Z2 ਨੂੰ ਰਿਪਰੈਜ਼ੈਂਟ ਕਰਦੇ ਹਾਂ। ਭਾਵ इथे वेक्टर OA कॉम्प्लेक्स नंबर Z1 ਨੂੰ ਰਿਪਰੈਜ਼ੈਂਟ ਕਰੇਗਾ, वेक्टर OB कॉम्प्लेक्स नंबर Z2 ਨੂੰ ਰਿਪਰੈਜ਼ੈਂਟ ਕਰੇਗਾ ਅਤੇ वेक्टर OP ਇਹਨਾਂ ਦਾ ਪ੍ਰੋਡਕਟ ਭਾਵ Z1 into Z2 ਨੂੰ ਰਿਪਰੈਜ਼ੈਂਟ ਕਰੇਗਾ, ਜੋ ਕਿ ਅਸੀਂ ਪਤਾ ਕਰਨਾ ਸੀ।
ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਜਿਓਮੈਟ੍ਰੀਕਲ ਰਿਪਰੈਜ਼ੈਂਟੇਸ਼ਨ ਆਫ ਪ੍ਰੋਡਕਟ ਐਂਡ ਕੋਸ਼ੀਐਂਟ ਆਫ ਟੂ ਕੰਪਲੈਕਸ ਨੰਬਰਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕੀਤਾ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਹੋਰ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Now let's see another example. If two complex numbers are Z1 equal to 4 into cos 5 pi by 6 plus eta sin 5 pi by 6 and Z2 is equal to 2 into cos 3 pi by 4 minus eta sin 3 pi by 4, then find the product and quotient of Z1 and Z2. Now its solution. Given complex numbers are Z1 equal to 4 into cos 5 pi by 6 plus eta sin 5 pi by 6 and Z2 is equal to 2 into cos 3 pi by 4 minus eta sin 3 pi by 4 . This implies Z2 can be written as it is equal to 2 into cos of minus 3 pi by 4 plus eta into sin minus 3 pi by 4 because we know that cos minus theta is equal to cos theta and sin minus theta is equal to minus sin theta. So here the given complex numbers Z1 and Z2 are in the polar form. So comparing Z1 and Z2 with the polar form for any complex number Z equal to R into cos theta plus eta sin theta, we get for complex number Z1 R1 is equal to 4 and theta 1 is equal to 5 pi by 6, and for complex number Z2 R2 is equal to 2 and theta 2 is equal to minus 3 pi by 4. Thus, the product of complex numbers Z1 and Z2, that is Z1 into Z2 is equal to R1 into R2 into cos of theta 1 plus theta 2 plus eta into sin of theta 1 plus theta 2. Now placing the values of R1, R2, theta 1 and theta 2, we get it is equal to 4 into 2 into cos of 5 pi by 6 plus minus 3 pi by 4 plus iota into sine of 5 pi by 6 plus minus 3 pi by 4 and that is equal to 8 into cos of 5 pi by 6 minus 3 pi by 4 plus iota into sine of 5 pi by 6 minus 3 pi by 4 and that will be equal to 8 into cos of 10 pi minus 9 pi upon 12 plus iota into sine of 10 pi minus 9 pi upon 12 further equal to 8 into cos of pi by 12 plus iota into sine of pi by 12 therefore product of complex numbers, that is z1 into z2, is equal to 8 into cos pi by 12 plus iota sine pi by 12 now quotient of complex numbers z1 and z2 is equal to z1 upon z2 is equal to r1 upon r2 into cos of theta 1 minus theta 2 plus iota into sine of theta 1 minus theta 2. So here, placing the values of r1 and r2, theta 1 and theta 2, we get it is equal to 4 upon 2 into cos of 5 pi by 6 minus 3 pi by 4 plus iota into sine of 5 pi by 6 minus 3 pi by 4 so it is equal to 4 by 2 into cos of 5 pi by 6 plus 3 pi by 4 plus iota into sine of 5 pi by 6 plus 3 pi by 4 on solving it is equal to 2 into cos of 10 pi plus 9 pi by 12 plus iota into sine of 10 pi plus 9 pi upon 12 that is equal to 2 into cos of 19 pi by 12 plus iota into sine of 19 pi by 12. Therefore, Z1 upon Z2 is equal to 2 into cos of 19 pi by 12 plus iota into sine of 19 pi by 12. Therefore, for the given example, for the given complex numbers Z1 and Z2, product of Z1 and Z2, that is Z1 into Z2 is equal to 8 into cos pi by 12 plus iota sin pi by 12, and their quotient, that is Z1 upon Z2 is equal to 2 into cos 19 pi by 12 plus iota sin 19 pi by 12. ਭਾਵ ਇਸ ਤਰ੍ਹਾਂ ਦਿੱਤੇ ਗਏ ਐਗਜ਼ਾਮਪਲ ਲਈ ਦਿੱਤੇ ਗਏ ਕੰਪਲੈਕਸ ਨੰਬਰਸ Z1 ਅਤੇ Z2 ਲਈ ਇਹਨਾਂ ਦੇ ਪ੍ਰੋਡਕਟ ਅਤੇ ਕੁਓਸ਼ੀਐਂਟ ਇਸ ਤਰ੍ਹਾਂ ਹਨ। ਭਾਵ Z1 into Z2 बराबर 8 गुणा cos पाई बटा 12 जमा आयटा गुणा sin पाई बटा 12 ਅਤੇ Z1 बटा Z2 बराबर 2 गुणा cos 19 पाई by 12 जमा आयटा sin 19 पाई by 12 जो कि ਅਸੀਂ पता करना ਸੀ। The product of two complex numbers Z1 and Z2 with polar coordinates R1 alpha and R2 beta respectively is R1 into R2 whole multiplied by cos alpha plus beta plus iota into sin alpha plus beta. The division of two complex numbers Z1 and Z2 with polar coordinates R1 alpha and R2 beta respectively is R1 upon R2 whole multiplied by cos alpha minus beta plus iota into sin alpha minus beta.
ਇਸ ਐਪੀਸੋਡ ਵਿੱਚ ਤੁਸੀਂ ਜਿਓਮੈਟ੍ਰੀਕਲ ਰਿਪਰੈਜ਼ੈਂਟੇਸ਼ਨ ਆਫ ਪ੍ਰੋਡਕਟ ਐਂਡ ਕੁਓਸ਼ੀਐਂਟ ਆਫ ਟੂ ਕੰਪਲੈਕਸ ਨੰਬਰਸ ਬਾਰੇ ਜਾਣਿਆ ਹੈ। ਉਮੀਦ ਕਰਦਾ ਹਾਂ ਤੁਹਾਨੂੰ ਐਪੀਸੋਡ ਪੂਰੀ ਤਰ੍ਹਾਂ ਸਮਝ ਆ ਗਿਆ ਹੋਵੇਗਾ।